Let's perform some experiments and see if we can conclude something from these experiments. Here we take 5 beakers containing equal quantity of water. We take a substance known as potassium permanganate having the formula KMnO4. It is a dark pink colored substance. Now we'll add this potassium permanganate to the second beaker. We leave the first beaker blank. We add it to the second beaker. Let's see what happens. Then a small part of this solution is taken out, added to the third beaker. A small part taken out, added to the fourth beaker, and so on. So you see the color fades. From dark pink, it becomes very light pink. Why did this happen? This is because when we add this substance, potassium permanganate, even a drop of this substance contains millions and millions of small particles. So a small drop contains millions of particles. When we dilute it, when we keep on diluting it, we take a small part of the solution, add it to a beaker containing water, we see that the color dilutes. This is because as we dilute it, the number of the particles of KMnO4, they keep on decreasing. As the number of particles decreases, the color fades. But each small particle retains the properties of the original substance, so we get a light pink color. This is what happens if you take a small part of this banana. You know, if you take a very small part, it will taste the same as the original bigger banana. So is it true for the small part of a watermelon? It still tastes the same. It has the same properties of the bigger watermelon. So the particles of matter, they are very, very small. Even a small part of the matter, a small particle retains the properties of the original bigger part. Now let's perform another experiment. We have certain balls and we'll try to arrange them in a certain frame. The task is to place them as close to each other as possible. So place them as close to each other as it is possible. You'll see even if they are placed very close, there are spaces in between. Well, let's take smaller balls now. Because we were getting very big spaces, let's try to do this with smaller balls. Perhaps we might not get some space this time. If you'll observe, even if we take smaller balls, we are still getting some spaces in between, even though they are placed very close to each other. So even though the balls are kept very close to each other and they are very small balls, still there are some spaces in between. The atoms or molecules of matter, they are assumed to be spherical in shape. So however close to each other they are placed, they still have some spaces in between them. These spaces are known as interparticle spaces or intermolecular spaces. So all the particles of matter, they have spaces between them. That is why when you add sugar to a glass of water, you see that the level remains the same. The level of water does not increase. Why is this happening? Because these are the particles of water. They have spaces in between them. So when you add sugar to this glass of water, these sugar particles, they take up the spaces that were present in between the water molecules. So that is why the level of water remains the same. This indicates that there are spaces in between the particles of matter. Okay, let's try something. Take a chalk piece and try to break it. You know it's very easy to break a chalk piece. You can even break it by one finger. Now try to break an iron nail. You know it's really difficult. Even if you use both your hands, you might not be able to break the iron nail. Why is that so? This is because the particles of matter, they attract each other by a force. This force is known as intermolecular force. Each particle of matter attracts the other particle by some force. This force is known as intermolecular force. In case of chalk particles, this force is weak. That is why we are able to break it. But in case of iron nail, these intermolecular forces are very strong. That is why even if you use both your hands, you are not able to break it. So all the particles of matter attract each other. What happens if there's a burning incense stick in one part of a room, or a person applies perfume standing on one corner of the room and you are standing on the other corner? Still you are able to smell the perfume, or you are able to smell the incense stick. How is that possible? Well, this happens because if this is a perfume bottle, as soon as you open it, the particles of perfume, they start moving. These are the air particles. They take up the space in between the air particles. So if a person applies perfume standing on one corner of the room, those particles start moving. Since they start moving, even if you're standing on the other corner of the room, you are able to smell it. So all the particles of matter, they are in a state of constant motion. So all these particles are constantly moving, and when they move, they collide with each other and with the walls of the enclosing area. So all these particles are always in a state of constant motion. So what did we just see from the experiments that we have performed? We saw that the particles of matter, they are very, very small. The particles have spaces between them, which we call intermolecular spaces or interparticle spaces. The particles attract each other by a force known as intermolecular force. And the particles are constantly moving. These 4 points form a theory. They form the postulates of a theory, which we call the kinetic theory of matter. Kinetic means moving. That is why this theory is known as kinetic theory, because the particles are always in a state of constant motion. So this theory gets its name as kinetic theory of matter. And these are the 4 postulates of kinetic theory of matter. They hold true for all the forms of matter, be it solid, liquid, or gas.